Yesterday on the worksheet. Class vote. I want to know. Raise your hand if you think someone asked you which class started. Raise your hand. I think pre-calc started. Raise your hand if you think pre-calc started. No. I said no. I think pre-calc started because it's like just a bunch of random disconnected topics.
Yeah, that makes sense.
You guys all took it all virtual. It was all virtual already. But like, I'm getting kids that are scared to take pre-calc. I'm trying to tell them like, pre-calc's hard. What will you tell people? Like specifically, someone's gonna come talk to you. Like I was just like saying, you can talk to people that are in the class. It was all over set. Like talk to them. Did you?
Yeah.
What was that?
Benjamin Camping.
You did it so bad.
I'm gonna make a video on this later.
That's the worst part right there. If he didn't.
Like one time he just gave us his test, like out of nowhere. He's like, "We're taking this test." It was like, what?
This was a student teacher for pre-calc
What?
Yeah.
last year.
Yeah.
Was a student teacher
He was
last year?
cool.
A male?
Yeah.
Benjamin Camping.
Oh, I remember him now. Okay, yeah. He got a job in the middle of the year. Wow.
No, we still have best friends. Dude, I thought he was awesome. Trent loved him. Zach, what? Wait, isn't there a dude?
Look at Giassi pointing out there.
I asked him.
It was really quick after, but I don't know if he had time to process it.
No, he did. He's the Riddler. He has everything. Right, I know where you live.
Because it's
Yeah, I did.
Is that the only answer?
No, there's 10.
Then 10. So that's like my first part. I'm gonna keep letting you work. I'm just talking to the first part if you're stuck. So I want to know the displacement and the distance, which means I need to integrate velocity, but I'm at acceleration. So I have to integrate acceleration. You got your plus c, you plug in the values, you can find out what c is, and then I know this is my velocity function. Set that equal to 0, and we're going to get 10 thirds, and we're going to get 10. 10 thirds is like 3 and 1/3, that is between these two numbers. I care about it. 10 is not between those two numbers, so I don't. Question on that first kind of part right there?
Oh, sure.
So if you're not done, keep going. If you're done, then wait for it. I was joking. I wanted to make sure you know I was joking. I don't want him to come home and be like, "This was fit." No, I was totally kidding. About like how you finish worksheets before I'm done explaining. A liar.
Yes. To find the displacement, they're both positive when you add them together. To find the distance, obviously negative one, positive.
That's backwards.
Is it? Okay. Find the distance, you add them both together. Both positive.
Think about this, like displacement is like, what place are you in compared to where you started?
Well, so bet with distance, you're gonna cover both distances traveled. Like you're gonna add up this distance. Displacement.
I walked to you 5 feet to give you a fist bump. I walked 5 feet. I'm in the same place I used to be, so my displacement is 0. Oh yeah, and if you run 800, your displacement is 0.
No, man, you're starting in lane 1.
Don't start the race.
You're at the concession stand.
You'd be like, I'm in this place. Okay, let me go through the next two parts. Or next part, I guess. I don't know. This is your velocity function. I'm going to erase this top part so I have some room to do some work up here. And then kind of think about it as a number line. Like I'm looking between 3 and 5. 10 thirds is around here. So it either is going to go like a positive velocity and then a negative, or a negative and then a positive. And just remember, like the displacement has to do with what place are you in relative to where you started. So if I walk to the back of the room 20 feet, and then come back 20 feet, I'm in the same place that I started. My displacement is 0. My distance is it's like a step tracker. Like I traveled 20 feet, so I walked 40 feet. So I gotta know the integrals, figure out the positive and negative, and then go from there. So I'm gonna set up an integral from, sorry, that's probably not super easy to see. From 3 to 10 thirds of this guy. And then I'm gonna set up an integral from 10 thirds to 5. And then you're just typing those in. You guys got those, or I should have type them? What do we got? What's the top one? Is that fair? And then okay. So this means I walked 1.15 backwards and then 23.15 forward. So my distance, I don't care which direction I walked, I had to take those steps. That was physical activity. Made me tired. 24.3. My displacement would be, okay, I walked backwards one. It's like vectors, like 1.15 backwards. And this far forward, so I believe that's 22. Is that right? Makes sense? Watch that. What? Are you good?
Yeah, you feel good about it?
Supposed to ask if you were good or something?
I did. I asked her.
Oh.
Yeah.
Do you appreciate that concern? Ethan's really worried about it. Yeah. Alright, get out the worksheet I just gave you. So we're gonna find the average value. So I've got a let's start about different. Let's jump to number, I don't know what number that is. I can't see the numbers. This problem, that's number 2. 4. Why are you guys saying different numbers?
It's 2. It's 4.
Thank you, Brian. Alright. Average value. So let's do this. Find the area that is shaded. Let's start there. I want to know the average value, which I'll get to in a second. But start off with finding the area under the curve, which is just the integral. So from 3 to 5. Is that the answer? Wait, who said 5.5? Oh, like exact or approximate? I would do exact. Oh, sorry. I would do approximate. I think you want to work with decimals. So I said you should be approximate. You said 16 thirds. Alright, so let's go with, I mean, we can do either one, but let's say it's 5.3333. Okay, so what that means is this area here, I mean, you guys know this, but this is 5.33. What the average value wants to know is if I were to put a horizontal line, I don't want to draw it. Where could I, if I put a horizontal line right here, I looked at the area below it, so let's go like this. That doesn't help at all. Alright, I'll just draw a bunch of lines. If I put a line right there, from 3 to 5, and said find this area, does that red line look, and I want the area to be the same. I want to draw a horizontal line and make a box where the area of that box is 5.333. So, for example, if I put that horizontal line here, does that box have the same area as the shaded area? It's too big, right? So, if I put it down here, does that box have the same area? That's too small. So the question is, where could I put that line? So it's like somewhere around here. would that box have the same area? Would that, can you see how that is close? That red box has closer to the same area as the shaded purple. Does that make sense what I'm going for?
Yes.
You can think about it like this. Like, this is, it works better if it's negative in this situation. Let me try again. You've got a curve like this. You've got a pool. You've got a pool full of water. Okay. This is your pool. It's got a weird curved bottom to it. You find out that there are 1,000 gallons in that pool. And the pool, yeah, can you shut up? The pool is 20 meters wide. So my question would be, where, if I wanted to have the same amount of water, but have a flat bottom instead of this curve, how far below the surface would I build the flat bottom? So, Evan, you're all over. So I want to know, like, right, I'm going to do something like this, where I put the exact, it's still a 1,000-gallon pool. I paid for a 1,000-gallon pool. I want a 1,000-gallon pool. I just want a flat surface instead of this curved garbage. How far below the surface would I build that pool? Do you see how it's just 1,000 divided by 20? Who said no? So, how do you find the area of a rectangle? Base times height. So, this is the base, this is the height, and when you multiply them together, you've got to get 1,000, right? So this has got to be 50 meters in this situation. So what did we do? Exactly what Devin said. We took the area and you divided by 20. Why? You divided by the base, right? Doesn't area divided by base give you height? Well, average value is the height. So, after all that, I know that the area here is 16 thirds. The average value is the area divided by the base. In this case, you would divide by 2. So the area is 16 thirds, or 5 1/3, whatever you want to say. And the base is just the distance between your two endpoints. So that'd be 16 thirds divided by 2, which is like 16 sixths, or 2 2/3, right? And again, what that's saying is if I could build a horizontal line at 2 2/3, so around there, that red box would also contain an average, or an area of 5 1/3. So it's just saying, like, the height here, you got a bunch of different heights in here. If I just scrap that and make it one height straight across, what height would it have to be to hold this in? And your formula is just this. Just the area divided by the base. The formula is easy, but I was trying to, like, help you understand where it came from. Does that make sense?
Yeah, that's tough.
Wait, when you say that's tough, is that like slang for that's good? Or is that...
Yeah, it's tough. That's hard.
No, but that sounds like it's hard. You don't understand.
No, that's tough. No, it's tough. To you have tough, not to you. Fair enough. That's you. Tough. Yeah, like that's tough. Yeah. And then there's no kidding.
So basically, you can do the whole thing on your I mean, you need your calculator to do it. It does not. Try number 1. What number is that?
What?
That's number 3.
3. Try number 3. What do you mean? What's the second part? Oh, crap! I didn't finish the problem, did I? Sorry. It's easy. It's easy. It's easy.
That was not tough.
It's easy. Your average value was, let's say, 16 sixths. So that's like here. So what the second part of the question asks is where does the function equal that value? So I'm looking for this intersection point right here. So you take your original equation And yeah, you're just gonna use solver, and you set it equal to 16.6. And you should get, I'm guessing, like 3.8 or something, it looks like. I don't know. But go ahead and do that. Put that in your solver. What is it? 3.8 repeating. So I forgot to teach that because it's like not that hard. Is that also tough? So try number 3. Once you're done with 4, try number 3. You take the area first. So anytime you're asked for average value, area divided by the base. The C is where the function equals your average value. So in this case, you probably have 2, because I'm guessing your average value is up here somewhere. So you'll have like 2 solutions for that. So you can do like solve negative x to the second minus 2x plus 3 equals answer. Like if you hit second and then the negative sign, it'll just grab your previous answer and put it in there. So you don't have to type the 1.666, you don't have to worry about the rounding. Do you guys know what I'm talking about that? The answer thing? You gotta do an answer for what? What? You too. So your average value is 1 2/3. It's like right here. Ish. So doesn't that cross 2 times? That's why you have 2. So I got negative 2.527 and 0.52527. You might get a third or fourth one sometimes, but if I got like 6, would I care about it? If I got 3 answers, this, and 6, what would I do with the 6? I would throw it out because it's not in our. It's not in our. 2.334. Wait, you said I got this one? Where's this 2.3? Are you doing like? Are you talking about finding the area? You just integrate. It does the positive negative stuff for you. I just integrated this from negative 3 to 2. No. So you're trying to figure out like displacement, distance, and that kind of stuff. Okay, then you should be able to add them up and get the same answer. Okay. But you don't have to split it up. Okay. Are we good on this one then? I don't know what you're saying. just like just mumble and say mean things. I don't know. I don't know. I don't even do it. How much attention do you need? No, I don't mean mean, Mackenzie. I just can't tell if you understand it or not yet. That's why. I solved. So this was my original equation. This was my average value, and I'm putting those two in solve to get my solutions. Other questions? I love questions. Bring it up. Well, I love some people's questions. I love math questions. No, 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 no. I love questions relative to the lesson. Let me be that specific for you, Mr. Sislow. What's your favorite number? What's your favorite mathematical operation? You would totally ask that question.
No, man, you can't just talk anymore because you just got you good.
You want to know that, don't you? My favorite mathematical operation.
Mackenzie asked that.
It's not yet. Are we good? Yeah. Top and bottom thing, what do you mean? Because that was the area between two different equations. So I had to find like the distance between those two different equations. Other questions? You guys good to get working?
Yeah, let's go. Let's go, brother.
Where do you make the box? You don't have to draw the box. Well, you can. I just draw it right on the. So like the average value is 1 2/3, so I just go here like around 1 2/3 and sketch a box. And like my red swimming pool would contain the exact same amount of water as this purple. So then you already did this. That's